In the previous example, we saw that we can construct the inverse for a one-to-one function by simply flipping the x and y coordinates. That means in example 5, if we're given a function, f of x, defined by this relation, then the inverse of f would be constructed by simply flipping those pairs. 10, 10 and 11, 11 would look exactly the same, but then we would flip the point 12, 14 to be 14, 12, and then 56, 13. If we have a one-to-one function, that's all we need to do in order to find that inverse function. In example 6, we're given a function written as an equation versus a relation. So here, we take the same approach. We'll begin by rewriting our function as y equals 2 over 9 plus x. Then to generate that inverse function, f of x, we'll flip the places of any x and y values. So we changed all of our x's to y's and y's to x's, and now we simply solve for y. We can do that by multiplying both sides of our equation by 9 plus y to get rid of our rational function. So this will give us x times that quantity 9 plus y is equal to 2. Dividing by x will give us 9 plus y is equal to 2 over x. And then subtracting 9 will give us y is equal to 2 over x minus 9. From there, we can take one last step. We can multiply 9 by x over x to get a common denominator and add those two expressions together to get y is going to be equal to 2 minus 9x over x. We flipped our values for x and y, we solved for y, and now we can replace y with this inverse function notation. So the inverse of f would be equal to 2 minus 9x divided by x. We can look at doing essentially the same thing in example 7. We'll begin by rewriting this as y equals 2x over 9x minus 5. To construct that inverse function, we'll first flip all of our x's and y's. And then we'll solve for y. To start that process, we'll multiply both sides by that denominator of 9y minus 5 to clear out our rational functions, which will leave us with x times the quantity 9y minus 5 is equal to 2y. Distributing through on the left-hand side will give us 9xy minus 5x is equal to 2y. From there, we'll look at collecting all of our y terms on one side of the equation. That will give us 9xy, and then if we subtract 2y over to the other side, and then we'll add 5x to the right-hand side in order to get all of our non-y terms over to the right-hand side. From there, looking at our two terms on the left-hand side, we can factor out that y that's common, which will leave us with y times the quantity 9x minus 2 is equal to 5x. And then divide to get y isolated on one side, and on the right-hand side we'll have 5x over 9x minus 2. That means our final inverse function, in this case, our inverse of g, will be 5x over 9x minus 2.